definitions of magnetic field. So from the equations of the magnetic force, we have F is equals to Q V B sine theta. This is the magnetic force which is experienced by the charge moving in a magnetic field. So from here, if I say that this charge, let's say it is 1 unit. When I say 1 unit, it may be 1 coulomb or 1 microcoulomb or 1 picocoulomb and so on. Similarly, the velocity is 1 unit, and theta, let's say it is 90 degree. So your force here becomes, instead of Q you write 1, V you write 1, B, if you write B, sine theta means sine 90 degree. Okay, so F, if you simplify the right hand side, you will get just B. Okay, so what does it mean? This magnetic field, it is numerically equals to the force. So hence, we defined, the magnetic field at a point as the force experienced by a unit charge moving with a unit velocity at right angles to the field. Okay, so in exams, if the question asks you to define the magnetic field in terms of magnetic force, then this is the definition. Now we will see about SI unit of magnetic field. So again, from this equation, F is equals to QVB sine theta. If you find out B, you will get F upon QV and then sine theta. Okay. So for the SI unit of magnetic field, right, we will find from this equation. So substituting the unit, of magnetic force is Newton. SI unit of charge is Coulomb. Velocity, it is meter per second. Okay, and this theta, it is the angle, so it is a supplementary unit, so we don't write for that. So finally, this SI unit of magnetic field, it will be Newton per coulomb per meter and then second. Alright, this is the SI unit of the magnetic field. Okay, so this SI unit of magnetic field, it is sometime written as Tesla. Tesla is the name of a person, and he is a very famous person because he is actually the first person to discover about the magnetic field. So therefore, in order to remember his name, the SI unit of magnetic field is given in his name, that is Tesla. So Tesla is equivalent to this unit. Alright, okay. Okay, this is about dimensions of magnetic field. So similarly, for the dimensions of magnetic field, you can find out that dimension, right, using this equation. So by substituting the dimensions of force, the dimension of charge, and the dimensions of velocity, then you'll get the dimensions of magnetic field. I will just write down the results here, right, for the for the calculation part, or regarding the how do you get that results, that you can do it as a homework. So this dimension here, it is m naught, and then ml naught, and then t minus 2 a minus 1. So this is the dimensions of magnetic field. So please do obtain by yourself, as usual, how to get this dimension. Alright, now After this, we will look at Lorentz force. So what is Lorentz force? So we know when a charge is moving in an electric field, that charge experience an electric force which is equals to QE. This is the force experienced by the charge in electric field. Similarly, when a charge is moving in a magnetic field, the charge experiences a magnetic force, which we write Fm, and that magnetic force is Q V B sine theta. So the total force of the electric and magnetic when a charge is moving in both the regions where there are electric and magnetic field, then the total force experienced by the charge is known as Lorentz force. So this Lorentz force, it is now written as F is equals to Fe plus Fm, or F is equals to Qe plus QVB sine theta, or F is equals to, if you take out Q common, then you get E plus VB sine theta, or you can say this Lorentz force is equals to, in vector form, this is the scalar form of the Lorentz force. So in vector form, this F arrow will become E arrow plus, instead of VB sine theta, I will write V plus B. So this is about the equations of Lorentz force.